Unit 5, Section 2, Derivative of a function. Section objectives. By the end of this session, the student will be able to 1. Obtain a gradient function from first principles. 2. Evaluate the gradient of a function at a given point. Derivative of a function. The derivative of a function is denoted as f prime. It is called so because it is derived from the function f. But let's note that if f is let to be y, then the derivative is denoted as dy over dx. And the derivative f prime is also a function or a gradient function whose value at x is given by f prime of x. Definition. The first derivative f prime of x is equal to the limit as h is approaching 0, the function f into braces x plus h minus f of x all over h. That is if the limit exists. Now basically, with this definition, when the function is given, we increase x by h, meaning wherever there is x, we increase it by h. Then we take the original function from what we obtained by increasing x by h, and divide it by h, then we take the limit at that point. Derivative of a function. Example, if the function f of x is equal to x power 3 minus x, use the definition given to find the first derivative f prime of x. So we are using the given formula to find the derivative of the function f of x, which means we are differentiating from the first principle. Now, the definition f prime of x, that is the first derivative of x, is equal to the limit x is approaching 0, the function f into braces x plus h minus f of x all over h. As we said earlier, wherever there is x in the given function, we increase it by h. So with the given function x power 3 minus x, we increase x by h, which gives the limit h is approaching 0, then into square bracket, then x plus h all to the power 3, meaning we increase x by h, then we raise it to the power 3, minus x plus h, meaning we've increased x by h, then minus x power 3 minus x, that is the original function f of x, all divided by h. Now simplifying, this gives x to the power 3 plus 3x squared h plus 3x h squared plus h to the power 3. Then minus x minus h, because the negative is affecting the braces x plus h. Then minus x to the power 3 plus x all over h. Let's continue in the next slide. Continuing from the last slide, the derivative of the given function f of x, that is f prime of x, is equal to the limit as h is approaching 0, then 3x squared h plus 3x h squared plus h to the power 3 minus h, all divided by h. Now the denominator h divides each of the term in the numerator, which gives the limit h is approaching 0, 3x squared h divided by h. The h cancels h, giving us the term 3x squared plus 3x h squared over h. The h squared divided by h gives h, giving us that term 3x h plus h to the power 3 divided by h gives h to the power 2, then minus h divided by h, which gives 1. Now this function is a polynomial, so we can now substitute h is equal to 0 into it. And that gives 3x squared plus 3x times 0 plus 0 squared minus 1. 3x times 0 is 0, 0 squared is 0, which gives the derivative as f prime of x, the first derivative of x, is equal to 3x squared minus 1.